Hi, everyone. Welcome to section 10.3. In this section, we are going to be using permutations and combinations, which is another technique on counting specifically. What are the objectives of this section? We wish to solve counting problems involving permutations and the fundamental counting principle. So the fundamental counting principle is what we already saw on section 10.2, which was n factorial. Multiplying and using the product property for that, and then solve counting problems involving combinations and the fundamental counting principle. So that tells us that there's going to be some factorials involved when we do both permutations and combinations. And then we're also going to be solving counting problems that are required to decide whether it's a permutation or a combination. So we're able to distinguish what type of problem we have. Do we have a combination problem or do we have a permutation problem? And within a question, we should be able to kind of identify some keywords that will allow us to use one or the other. Let's begin with a permutation. So in the context of counting problems, arrangements are often called a permutation, where the permutation of n takes things from n and permutes them in R. Applying the fundamental counting principle, it looks like NPR, which is going to be defined by using the formula n factorial over n minus r factorial. And this is one of the formulas that you can use when you're using NPR. There's also a way on your calculator to use NPR. And if I'm going to go ahead and share that with you, let me go ahead and open up my calculator, which is Calculate 84. And then let me open it up, and then you'll able to see how to use a permutation. So you're going to say math and then prob. And then you see the second one, it says NPR like that. So you're going to tell it NPR. So then you're going to move to the other cursor and then put R. So N is going to be a value, R is going to be another value. N is always going to be greater than R because N is the sample space and R is the selection. So where N is strictly greater than R when we're looking at a permutation. Now, we have this factorial formula for permutations is that we are going to take, again, R to be less than or equal to N. It can be calculated using this formula, N factorial over N minus R. You're going to be taking arrangements of n distinct things at r times, where here a permutation order matters. That's key. So the order of the arrangements matter when we're doing a permutation. Now, let's go ahead and solve using the factorial formula. We're going to use both the calculator and compute it by hand. So for letter A, 5 permutes 3. Let's say n to be 5 and r to be 3. So we're going to use 5 factorial over 5 minus 3 factorial because the permutation formula is n factorial over n minus r factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1, and then over 2 factorial. So 2 times 1 is the same as 2 factorial. So it's 5 times 4 is 20, times 3 is 60. We can also use our calculator, and then let's do it using our calculator. 6 permutes 6. So if I want to do 6 permute 6, again, when you're doing your homework, you're allowed to use your calculator. So I want to say 6 and then math and then move to prob and then the NPR 6. So it's 6. Let me remove the first 6. Let me remove everything. And then again, let me put math and then move it to prob NPR. So it's 6 permutes 6. So 6p6 and then hit enter, and that should be 720. We can also calculate this by hand. Again, if we are trying to do this by hand, we have 6 factorial over 6 minus 6 factorial. It's 6 factorial over 0 factorial. But 0 factorial is 1, and 6 factorial is 720. So then the answer should be 720. Oops, 720. Now, when we're building numbers from a set, so how many they're already telling us we want to find how many four-digit number can be written using the number sets 1, 2, 3, 4, 5. So n is 5, the sample space, and you're selecting 4. And then it's saying repetitions are not allowed. So when we are doing order matters because order matters, we are going to use a permutation. So we were able to identify n, which is our sample space, which is always going to be greater than the value of r. So 5 permutes 4, 5 factorial over 5 minus 4 factorial. Again, 5 factorial is 120 over 1 factorial, which is 1 or 120. Again, you're more than welcome to use your calculator, but it's important to know how to do it by hand. So whenever you have that keyword, repetitions are not allowed, that means that order definitely matters, so it's important. So when order matters, that means we're dealing with a permutation. Alrighty, so let's look at number 4. How many ways can you select? So you're selecting 2 letters followed by 3 digits for an ID. So there's 2 parts. So repetition is not allowed, so you're going to have 2 different permutations. So the first permutation is you're selecting 2 letters from the alphabet. So the first part is you're selecting 2 out of 26 because there's 26 letters of the alphabet. So this is R, this is N. And then the second part is you are selecting 3 digits from 9 digits. So N is 9 digits, R is 3 digits because this is a selection of digits. So then we're going to do 9P3 and then 26P2. So we'll have 26P2 times 9P3. So when we multiply and identify, okay, well, how many, well, digits will have 0, 1, 2, it's actually 10, 10P3. So it should be 10 digits total. 10, so N is 10, excuse me, there's a typo. 10 digits because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 digits. So N is 10 and 3 is my selection. So I'm going to go ahead and use my calculator, 26P2 times 10P3 because there's 10 digits that you're selecting. So I'm going to go to my screen here and let me clear it. So I want to do math and then prob. Let me go back. So let me go to math and then move to prob and then move to NPR. So I have 26 will permute 2. Take that number. I'm going to put a parentheses on that number. And then I'm going to multiply that by math prob again down with NPR, enter. Now I'm going to do 10 because those are the digits. And then I want to be very specific and I want to use parentheses as well. That way I'm enclosing what I want enclosed and then 10 permutes 3. Close it and that should be a total of 468,000. So make sure that you're using parentheses when you're using your calculator. That way you are separating the 2 different permutations and then taking the product of those permutations. Alrighty. So make sure that you pay attention to little details. So selecting 2 letters followed by 3 digits and then digits. There's 10 digits out of the entire. And that was a permutation. So what's the difference between a permutation and a combination? So now in a context of a counting problem, now subsets where order does not make a difference, that is called a combination. So this is when order does not matter. So here in the terms like of repetition or things of that nature, you have when you have the word a committee, that's when you want to use a combination. So the number of combinations of n things taken at r amount of times. So we have the same way we had a permutation, we have a combination formula. The combination formula, it's defined as n factorial over r factorial, n minus r factorial, where NCR, it's the same. It doesn't see how here the R is first, but then it's on the bottom. That's okay. So the location of where it is, it could be the n minus r first and then the r. So technically what you're doing is you're taking NPR and then dividing it by r factorial. In nature, that's what it is. So those are the two formulas to kind of distinguish between a permutation and a combination. Now, how would we evaluate a combination? So the first thing you want to do is 5CR. So then n is 5 and r is 3. So we use the formula n factorial over n minus r factorial. That will place me at 5 factorial over 5 minus 3 factorial, 3 factorial. So then the 5 factorial is the same as 120. So it's 5 times 4 times, so it's 5 times 4 factorial over, I have 2 factorial, 3 factorial. Well, 4 factorial is 24, and then 24 times 5 is 120. So we do 120 over 2 times 6, which is 12. I get 10. So 5C3 is 10. Now I can also use my calculator. So I'm going to use my calculator for 6C6. So I showed you how to do a permutation on the calculator. Now I'm going to show you how to do a combination. The combination is actually very similar. What you're going to do is you're going to go to Math, Prob, and then instead of doing NPR, you're going to do NCR. Hit Enter. And then here there's some ads because it's a free calculator. You'll see some ads once in a while. I'm trying to get rid of those ads. Um, so let me go back to my calculator. Let me see my screen here. Let me see. I want to use calculate 84 and I can exit out now. Okay. Alrighty. So let me take you back to calculate 84. So I did NCR. So it's 6 combination with 6. I hit enter and that's going to be 1. So 6 factorial over 6 factorial will give me 1. Now, that would be for a combination. Now, the next thing I want to do is a few examples on how to find numbers of possible poker hands. So let's look at the question. A common form of a poker involves a set of 5 cards on each, dealt with, so there's 52 different cards. How many 5 different cards are possible? So they're already saying that their total number of cards are 52, and your selection is 5 because you're selecting 5 cards on each deck. So then if we're doing 52 combined with 5, then we're able to kind of punch this in our calculator and go, okay, well, that's going to be equal to Math, and then we're going to go to Prob and then NCR, and then we'll do 52, and then 5, and then hit enter, and that's going to be 2,598,960. That is the many ways we can obtain, where of course, again, repetition are not allowed and order is not important. So when we're looking at a poker game, it doesn't really matter the order. Repetition, of course, is not allowed. So the repetition part is still the same as a permutation, except the order when you're doing a poker doesn't really matter. So then you'll do 52 combined with 5. So then again, you're using that formula n factorial over r factorial n minus r factorial. Now, when we're looking at subsets, another way to kind of look at combinations is to look at subsets. So we want to find the number of different subsets of size 3 in the set math rock. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the sample size is n is equal to 9, and we want a subsets of size 3. So r is equal to 3. So then it's going to be n factorial over r factorial n minus r factorial. It doesn't say anything about the order, so it doesn't really matter the order, but it does matter that we're looking at a particular subset. So when we're dealing with a subset, that means that order will not matter in this case, so we're using a combination. So then if we're trying to figure this out, we'll have 9 factorial over 3 factorial, 9 minus 3 factorial. That will give me 9 factorial over 3 factorial, 6 factorial. So 9 factorial is 9 times 8 times 7 times 6 factorial over 3 factorial, 6 factorial. So you can cancel, you kind of simplify with 6 factorials. 3 factorial is the same as 6. So you have 9 times 8, that's 72. So 72 times 7, it's 504 on the top divided by 6 because 3 factorial is 6. So then if we do 504 divided by 6, we'll get 84. So then my solution will be 84. Again, you're more than welcome to use your calculator and double check. You may do that too. And then how to kind of distinguish the guidelines if we have two different things, where to kind of distinguish between a permutation and a combination. Well, when you're given a permutation, you want to find the number of ways of selecting R items out of 10 or out of, n items. So same thing as a combination. Repetitions, both of them are not allowed, but the difference is order is important when you're doing a permutation versus not important when we're doing a combination. So two different things. Now, for a permutation, you're looking at a specific arrangement of n items, and then in a committee or in a combination, we're looking at subsets. The formulas are also different. So what are the keywords that you can kind of distinguish arrangement, schedule, and order? Those three kind of keywords are something that will mean that we will need to use a permutation. Whereas another group would be, for a combination, would be a group, a sample, selection, subset, and then maybe just add subset and committee. So that would be another way to kind of distinguish between the two, where order does not matter. Now, if we're looking at example 3, we are trying to identify what types of ways or what method are we going to use? Are we going to use a permutation or a combination? So let's go ahead and read the question. In how many ways, so again, we're doing a counting principle, in how many ways can a parent distribute 3 toys among 7? So there's 7 children. If a child may receive anywhere from none to all 3 toys. So you are how many? You're selecting 3 different toys among 7 children. Does order matter in children? No. So when you're dealing with the children, the total number of children n would be 7. You're selecting 3 toys to give. So you're going to do, in this time, a combination. So you're doing a subset between some kids. And then because a child can repeat the people, so here now you have to look at repetition. So we're just going to be using our counting principle. How many selections can we have? So we have only 3 toys and can split it among the 7. So 7 times 7 times 7 would be 343. So now it is important for us, if we would say that repetition is not allowed, then we would use a combination. Now, it doesn't really say anything about the distribution, so repetition might be allowed. So because it doesn't mention any, if would say repetition is not allowed, then we would use a combination. But because it doesn't say anything about repetition, so we will assume that repetition is allowed. Now this one's a little bit different because every member of the Alpha Beta Gamma fraternity would like to attend to a special event. but only 10 members are allowed to attend. How can the lucky 10 be selected of a total 48 members? So again, it doesn't really mention anything. So it's saying only 10. So the word only 10, it means that there's a unique way, that means that you're only selecting 10. So R is 10 and out of the total and 48 here. Order does not matter, so it doesn't matter what order I choose it. So then that means I'm going to have order makes no difference of the selection. So when I'm selecting, and remember that word selection. So selection was a keyword, for a combination. So we do 48 combines 10. And then let's go ahead and plug this in our calculator to kind of use and be familiar with the process. So we'll go to math and then we'll go to prob and then we're going to go to NCR and then we'll put 48 N, that was N, and then we're selecting 10 lucky people. And that's going to give us 6.5. And this E9, that means 9 units to the right side. So if I do if I copy 6.54540715896 E9, whenever you see that E9, it means that you move your decimal place 9 places. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 65407158846. So it's 6,540,715,846. Those are the different ways 10 people can be selected out of 48 members. And with that, we terminate section 10.3. Thank you, and I'll see you guys next time. Have a good one. Bye-bye.